In this video we're going to talk about Python control structures. So we'll make a new notebook for that. Okay, so the most basic control structure is a loop. Okay, so we do for I in range 1 to 10, so it's going to go, I is going to go through all the numbers from 1 up to 9. So we'll set j to be equal to the square of I, and then we'll print it. And let's do, we'll print this using a format string, so like this, so we're going to say the square of I, and we're going to sort of fill in the value of I, so we put the I in curly brackets, and then we put j in curly brackets there. Okay, so we go through the loop and we print all the squares. So it's a very basic thing. Okay, well, let's do a while loop, which is a kind of rather similar thing, but just a tiny bit different. Okay, so we're going to start searching for squares that are at least as large as 42. Okay, so we're going to do the same sort of thing here. We don't. Let's suppose we pretend that we hadn't actually worked out in advance so how far we'd have to go. So we're going to start with I being 1, and then so we're going to kind of wait whilst I times I is still less than 42, okay, so if I squared is less than 42, then we're going to just print a message to say that. So notice here, I'm in the previous example, I sort of set I star I to be a variable j, and then I put the j in curly brackets. But I'm also allowed to just kind of put the whole expression I star I inside curly brackets instead. So we do that. Okay. So now, but if I just do this, then I is going to be equal to 1, and then we're just going to keep saying square of 1 is 1, which is less than 42. And then we'll just keep doing that again and again and again without anything changing. I mean, the point is supposed to be that we're going to we want to increase I if it's too small. So we have to put in I is I plus 1 here. Okay. Okay, so now we go through this loop where we square of 3 is 9, less than 42, etc. Square of 6 is 36, which is less than 42. And then we come around to here, and at this point I star I is greater than or equal to 42, so we stop. And we could, if we want, we put in an explicit message for that. Once we get to this point here, once we get to this point, we've kind of dropped out of this loop. This test here, which would keep us in the loop, must have failed. So I star I must be greater than or equal to 42. Just run it through it again. Yeah, so it all goes through, and then we drop out of the loop with I being equal to 7. And so we print the square of 7 is 49, which is greater than or equal to 42. So that's a typical example of a while loop. This is maybe not such a typical example because we've done this kind of very, very simple thing of just incrementing I here. But sometimes you do something more complicated will happen in the body of the loop. So let's do another thing. It's somewhat similar to a while loop, but we're going to do a for loop like we had before. but in a for loop with a breaking, with a possibility of breaking out of the loop early. Okay, so we're going to try and find the square root of a number. Let's call it, say, 196. We're going to try and find the square root of that. And so in a set of variables to say that we haven't actually found it yet. So we're going to search. I is going to run in the range up to 999. For each of those values, we're going to check check if I squared is equal to m. And this is extremely inefficient, but it will serve to just illustrate how these kind of loops work. Okay, so if it's true, then that means that we've found a square root, and we're going to print it. Okay, so we've got I squared is equal to m, so we found the square root of that. And at this point, we're going to break out of the loop. There's no point carrying on looking at the further values of I if we've already found the right one, so we've got in a break statement. Okay, so then, so now it tells us the square root of 196 is 14. Let's try a different number, 197, say. It just doesn't print anything. Why is that? I mean, that's just because it didn't find a square root, because there is no integer square root of 197. But it would be better if we actually had some message about that. So we'll put in an extra message here. So the point is, we only need to print a message if we haven't found it. So that's why we kind of put in this thing called found to check whether we had a record of whether we'd actually found the root. So we get to this end here, we haven't found the root, then we're going to print a message. Okay, so no square root of 197 is found. We put in something that is a square, tells us the square, tells us which thing it is. Okay, so yeah, so there's a little thing to find integer square roots. As I say, I mean, if you're really interested in this, there are far better ways of doing it, but this is at least nice and simple. But let's actually also turn it into a function. It's generally better to do these kinds of things as functions. So so our first variable is going to be the integer m, whose square root we're supposed to find. And then the other kind of thing here, we've got this sort of random constant of 1,000. It's better not to have sort of random constants sort of without any names known to them. So what we're going to do here is we're going to have a second argument, which is going to be the max range we're going to go to. But we're going to have a default value. We're going to put in max range is 1,000, which means that if we don't specify the maximum range, then it's going to be 1,000. Okay, so then everything has to get indented one more slot to follow the usual Python indentation rules. And here, we might as well instead of just breaking, which would just push us further down, it's better if we just actually return the value that we found. Okay. And in fact, because we're doing the return here, that we don't actually need the found thing anymore. See, if we actually found the square root, then we're going to just jump completely out of the function, so we won't get to this point here. So If we get to this point here, then it follows that we can't possibly have found the square root, so we can just print a message to that effect, and then we could return none. That's probably a reasonable thing to do if we haven't found a square root. So now we've got to find our function. So we can find the integer square root of square root of 625 is 25. That's good. Oh, and actually, so we made a mistake here. You see, it's telling us the return value is 625, but that's because we returned m. We shouldn't have returned m. We should have returned I. I is the square root. So there we go. So we've printed it and returned it, which is probably not the tidiest thing to do, but it'll do for the time being. Okay, we'll do one more little example. We're going to do the game of FizzBuzz, which is a very standard programming exercise. Well, what's FizzBuzz about? We're supposed to, if you're given a number, you're supposed to just you're supposed to say the number, except if the number is divisible by 3, you're supposed to say fizz instead of saying the number. And if the number is divisible by 5, then you're supposed to say buzz instead of saying the number. And if it's divisible by both 3 and 5, you're supposed to say fizz buzz instead of saying the number. So like a little kid's game. So we're going to define a Python function to do this. Okay, so so what are we going to do? So certainly we need to test whether our number is divisible by 3, and then we also need to do something if I is divisible by 5. So the tidiest way to do it is let's let S be just the empty string, and we're going to put the words in S. Okay, so if I is divisible by 3, then instead of the empty thing, we're going to do fizz. I is divisible by 5. Well, I could say S equals buzz, but then I would have to do a kind of separate thing to see whether it's divisible by both 3 and 5. It's actually more convenient to do it this way, right? I mean, if I do S plus buzz, okay, so then if there was a plus, just connects the strings onto the end of each other. So here, if it's divisible by 3 and 5, then it will I'll already have a fizz, and then when I do S plus buzz, then I get fizz buzz. That's how it's supposed to be. Okay, so that's so now we get to this point here. So S might be fizz, or it might be buzz, or it might be fizz buzz. But if we haven't, if it's not divisible by 3 or 5, so we haven't got a fizz or a buzz, then we're supposed to just say the name of the number itself. So if we get to this point, S is the empty string. That means that neither of these things have happened. So it's not a fizz or a buzz. It's not divisible by 3 or 5. So in this case, you can say S is equal to I, but it's probably kind of tidiest to sort of explicitly convert I to a string, right? S was an integer. Well, Python would sort of automatically convert it to a string if it had to, but it's tidier to be explicit about it, and we'll convert it to a string here. Okay, so there's our FizzBuzz function. So FizzBuzz of 100, it's not divisible by 3, it is divisible by 5, which we should get a buzz. You do 101, now 101 is not divisible by 3 or 5, so that should just give us the string 101. 102 is divisible by 3, but not by 5, so we get a fizz. 105 is divisible by both 3 and 5, so you get a fizz buzz. Okay, so let's actually do a kind of loop on that. So here's just a list of things. You get, so let's actually start at 1 rather than 0. So range 120, 1, 2, and then 3 becomes fizz, 4, and then 5 becomes buzz, and so on and so on. Down to 15 becomes fizz buzz. Let's actually just check the numbers themselves. So so now it's telling us the numbers and also the strings. So now we're seeing it's 15 gives us the fizz buzz and 18 gives us the fizz and so on. It's just slightly untidy because these the colons are not lined up. So let's do something a little bit fancier with these format strings. If I just put a colon 2 there, then that'll ensure that it's always 2 characters for the I. Okay, so now that by putting that colon 2 in here, I pad this out with a space, so everything lines up neatly. And that's all we're going to say for the minute about control structures.